Right now, far beyond the planets, far beyond the protective reach of the Sun, an ancient spacecraft is still speaking to Earth. Voyager 1 is not supposed to be doing this. It was built in the 1970s, before modern computers, before the internet, before most of the people studying its data were even alive. It was designed to last a few years, fly past Jupiter and Saturn, send back images, collect measurements, and then disappear into silence. But it never stopped. It kept moving. It crossed the edge of the solar system. It entered interstellar space. And now, from a place no human-made object had ever reached before, Voyager 1 is telling us something that does not fit the models. The space beyond our solar system is not quiet. It is not smooth. It is not the empty black ocean we imagined. It has a hum. It has turbulence. It has a violent boundary wrapped around our solar system like a hidden shield. And the strangest part is this. What Voyager 1 found out there is not only about deep space, it is about us. Because the same boundary Voyager crossed is the barrier that helps protect Earth from the raw radiation of the galaxy. So when Voyager 1 looked back across that frontier, it revealed something we cannot fully explain yet, and something that may change how we understand the survival of life inside the Sun's bubble. Voyager 1 launched on September 5, 1977. Its original mission was simple. Visit Jupiter, visit Saturn, take photographs, gather data, complete one of the most ambitious planetary flybys ever attempted. That was supposed to be the story. A brilliant mission. A few years of operation, then silence. But Voyager 1 became something else. In 1979, it passed Jupiter and sent back close-up images and measurements that changed our understanding of the giant planet. In 1980, it passed Saturn, revealing details of its rings, moons, and magnetic environment. Then, gravity did the rest. The outer planets did not just give Voyager 1 targets, they gave it speed. Each flyby acted like a gravitational slingshot, throwing the spacecraft farther and faster into the dark. By the end of the 1980s, Voyager 1 was already farther from Earth than any human-made object had ever traveled. And it was still alive, still transmitting, still measuring, still sending its thin radio signal across a growing ocean of space. Then, in 2012, Voyager 1 did something no human machine had ever done. It crossed the heliopause. This is not just a distant region beyond the planets. It is the true outer edge of the Sun's influence, the place where the solar wind finally loses its strength and interstellar space presses inward from the other side. Everything inside that bubble belongs to the Sun. The planets, the moons, the asteroids, the comets, Earth, every living thing that has ever existed. But outside the heliopause is something else entirely. The space between stars, the ancient plasma of the galaxy, the region shaped not by our Sun, but by the wider Milky Way. When Voyager 1 crossed that boundary, it became the first human-made object to enter interstellar space. And because it kept transmitting, humanity suddenly had something it had never had before. A live instrument on the other side of the solar system's wall. And what it found there was not what the models predicted. For decades, scientists built models of what interstellar space should be like. The expectation was not that it would be perfectly empty. Space is never truly empty, but the plasma between the stars was expected to be thin, cold, and relatively smooth. A quiet background outside the Sun's protective bubble, then Voyager 1 entered it, and the quiet disappeared. Starting in 2017, Voyager 1's plasma wave instrument began detecting a persistent narrow band emission, a hum, a faint continuous vibration in the plasma of interstellar space. Not a single burst, not a temporary shock wave, not one suspicious reading that could be dismissed as noise, a signal that continued year after year across an enormous distance as Voyager 1 moved deeper into the space between stars. This is where the discovery becomes extraordinary, because that hum gives scientists a way to measure the density of interstellar plasma continuously. Before this, researchers could only get scattered snapshots, often when solar eruptions sent disturbances all the way out to the boundary and caused the surrounding plasma to respond. That was useful, but incomplete, like trying to understand the weather of an entire planet by measuring one storm every few years. Voyager 1 changed that. The persistent emission became a kind of running feed, a real-time trace of the interstellar medium around the spacecraft, and what that trace revealed was unsettling. Interstellar space has structure, it has density changes, it has turbulence, it has motion and complexity at scales that older models did not fully capture. The universe beyond the solar system is not a calm waiting room between stars. It is active, it has texture, it behaves almost like cosmic weather. And Voyager 1 is the only spacecraft inside that weather measuring it directly. But the hum still raises a major question. Scientists are still working to determine exactly what physical process creates it. It may be thermally excited plasma oscillations, natural vibrations inside the plasma. Or it may be quasi-thermal noise, a different mechanism that could reveal density and temperature in a way that forces models of the interstellar medium to be revised. Either way, the message is the same. The space outside our solar system is more complicated than we thought, and Voyager 1 is detecting it before we fully understand what it means. The hum was not the only surprise. Before Voyager 1 fully entered interstellar space, it crossed the heliopause itself, the boundary where the sun's solar wind meets the pressure of the galaxy. Scientists expected this region to be unusual, but many models imagined a relatively gradual transition. Solar particles thinning out, interstellar particles becoming more dominant, a kind of smooth blending between the sun's environment and the space beyond. That is not what Voyager 1 found. At the edge of the solar system, particles were moving at extreme speeds. Charged particles were colliding, compressing, and generating temperatures approaching tens of thousands of degrees, not inside the sun, not inside a star, at the outer boundary of our solar system. This is why some researchers describe it as a wall of fire, not fire in the ordinary sense. There are no flames out there, no burning surface, no oxygen. But the energy is real. A dense, violent concentration of charged particles forms a hot, turbulent frontier around the sun's protective bubble. And that frontier matters deeply. Because the heliosphere is not just a cosmic border. It is a shield. It helps deflect dangerous, high-energy cosmic radiation that comes from outside the solar system. Radiation created by violent events across the galaxy, including exploded stars. If the heliopause is more turbulent, more energetic, and more connected to the interstellar environment than scientists expected, then the shield protecting the inner solar system is also more complex than expected, and that means the implications reach all the way back to Earth. Voyager 1 also detected surprising magnetic behavior at the boundary. Scientists had expected the sun's magnetic field and the galactic magnetic field to be more clearly separated. But Voyager found evidence that these magnetic environments are connected and interacting through processes that release energy. The solar system and the galaxy are not isolated from each other. They are linked. At the boundary between our home and interstellar space, magnetic fields rearrange, particles accelerate, and energy is exchanged between the sun's bubble and the wider cosmos. That is not a small correction. It changes the way we think about our place in the galaxy. Earth is not sitting safely inside a sealed dome. It is inside a moving, breathing magnetic bubble that is constantly pushing against an active interstellar environment. And Voyager 1 is the only witness we have on the outside. The most dramatic part of this story may not be the discovery itself. It may be the fact that we almost lost the machine carrying the answer. In 2023, Voyager 1 began transmitting corrupted data. The spacecraft was still alive. The radio signal still reached Earth. But the information inside was unreadable, scrambled code from the most distant machine in human history. For 5 months, engineers faced a nightmare. Voyager 1 was more than 24 billion kilometers away. No one could repair it physically. No spacecraft could reach it. Every command sent from Earth took almost a full day to arrive, and every response took almost another day to return. One question, 2 days of waiting, one adjustment, 2 days of uncertainty. Eventually, the cause was traced to a single degraded memory chip inside the flight data system. One tiny piece of hardware, after decades of cosmic radiation, had corrupted the software responsible for formatting Voyager's science data. That tiny failure nearly silenced humanity's only instrument in interstellar space. But the engineers found a way around it. They split the damaged code, moved pieces into healthy parts of memory, and reconnected the logic from across billions of kilometers of void. It was like performing brain surgery on a machine from the 1970s with a 2-day delay between every movement. And it worked. Voyager 1 came back. Readable science data returned. The hum continued. The map of interstellar plasma began drawing itself again. But this victory cannot last forever. Voyager 1 is dying. Its radioisotope power source loses energy every year. Instruments have already been shut down. More will follow. Every watt now matters. Every decision means choosing which part of the spacecraft survives a little longer and which part goes dark forever. And in the coming years, Voyager 1 will cross another symbolic threshold. It will become one full light day from Earth, so far away that a signal traveling at the speed of light will take 24 hours just to reach it. A command sent on one day will not receive a response until 2 days later. No human-made object has ever reached that kind of distance while still alive, but the power is fading. Sometime in the early 2030s, unless engineering miracles stretch the mission further, Voyager 1 will go silent. When that happens, the spacecraft will not stop moving. It will continue drifting through the galaxy for millions, perhaps billions of years, carrying the golden record, the greetings, music, sounds, and symbols of Earth. But the science will end. The live signal will be gone. The hum will continue in interstellar space, but we may no longer have anything there to hear it. And that is the real urgency. Voyager 1 has turned the edge of the solar system into a mystery. It has shown us a turbulent interstellar environment, a hot and magnetic boundary, and a protective shield more complex than we expected. But the only machine that can keep measuring it is running out of time. The discovery we cannot explain may still be unfolding, and the witness may die before it finishes speaking. So, what did Voyager 1 really discover when it crossed the edge of our solar system? It discovered that the boundary between our world and the galaxy is not quiet. It is not smooth. It is not a clean line where the sun simply fades and interstellar space begins. It is alive with motion, a turbulent frontier of plasma, magnetic fields, charged particles, and energy. A place where the solar system does not end gently but struggles against the galaxy, pressing in from the outside. That may be the most important lesson Voyager 1 has ever sent back. For decades, we imagined the edge of the solar system as a distant, cold border, a fading region beyond the planets where the solar wind weakened and the interstellar medium slowly took over. But Voyager 1 found something far more complex. It found a hum in the darkness, a persistent, narrow emission running through interstellar plasma, continuing year after year across enormous distances. A signal that tells us the space between stars is not empty, not uniform, and not silent. It has density. It has structure. It has turbulence. It behaves almost like weather in a region we had never been able to enter before. And Voyager 1 is not observing this from far away. It is inside it. That is what makes this discovery so rare. Every telescope on Earth studies the universe from within the sun's bubble. Every model built before Voyager crossed the heliopause was in some sense an educated guess from the inside looking out. But Voyager 1 crossed the wall. It moved beyond the sun's protective reach and began measuring the galaxy directly. And what it found changed the picture. The heliopause was hotter, more violent, and more magnetically connected than expected. Charged particles moved with enormous energy. Magnetic fields from the solar system and the wider galaxy interacted and reorganized. The boundary that protects the planets was not a simple shell, it was a battlefield. And that battlefield matters to every living thing on Earth because the heliosphere is part of our protection. It helps shield the inner solar system from some of the most dangerous cosmic radiation traveling through the galaxy. If that shield is more turbulent and more variable than our models predicted, then our understanding of Earth's cosmic environment is still incomplete. This is not just deep space science. It is about the invisible system that surrounds our home. The bubble we live inside, the shield we never see, the frontier that separates everything familiar from the raw environment of the Milky Way. Voyager 1 did not simply discover what lies beyond the planets. It revealed that our entire solar system is interacting with the galaxy in ways we are only beginning to understand. And yet, the machine telling us this is dying. That is the tragedy at the center of the story. Voyager 1 survived almost 50 years. It survived the radiation around Jupiter. It survived the cold. It survived the distance. It survived the heliopause. It even survived a corrupted memory chip that nearly turned its final years into unreadable silence. Engineers brought it back from more than 24 billion kilometers away, rebuilding its logic through commands that took nearly a day just to arrive. They performed the closest thing to remote brain surgery ever attempted on a spacecraft. And somehow, Voyager 1 spoke again. But no repair can stop time. Its power is fading. Its instruments are being turned off. Every watt is now precious. Every system that remains alive costs energy the spacecraft cannot replace. At some point, the final instrument will shut down. The transmitter will weaken. The last signal will leave Voyager 1 and begin its long journey home. And when that signal reaches Earth, there may be nothing after it. Voyager 1 will keep moving, of course. It will continue through interstellar space, carrying the golden record, carrying the sounds of Earth, carrying greetings in human languages, music, laughter, rain, ocean waves, and a map showing where we came from. But it will no longer be a witness. It will become a monument, a silent artifact drifting through the galaxy, and the hum will continue without us. The plasma will still vibrate. The heliopause will still shift. The magnetic fields will still reconnect. The galaxy will still press against the sun's bubble, but humanity may no longer have a living instrument there to listen. That is why this moment matters. Right now, in this narrow window of history, we still have one machine beyond the wall, one machine inside interstellar space, one fragile, ancient, underpowered spacecraft still telling us what the universe is like where no human technology has ever stood before. Voyager 1 turned the edge of the solar system from a line on a diagram into a place. A real place. Hot, turbulent, magnetic, unfinished, and still not fully explained. The discovery is not over. The signal is still coming. But the clock is running out. And maybe the most haunting truth is this. We finally reached the space between stars, just in time to hear it whisper before our only listener goes silent.